Hi, thanks for checking out our channel. This is going to be a hopefully repair video on this unit. This is a biggest Cyclops unit the biggest unit that Cyclops produces. 41 stored joules, 32 output. The one thing about this people don't know when they buy one of these is that these are not full 32 joules all the time. They have a technology that they put in these things called power on demand, they call it. Some brands call it adaptive control. Some brands call it something else. But on these bigger 15, 20 joule models and larger, not all brands do this, but some of them, you need like you don't need to be using all the power all the time because you're going to overheat the thing inside if there's not enough fence load out there to absorb all the energy these things are trying to produce. So they have a power on demand. So the first like 5 to 10 pulses, it pulls at full power. And until it determines, okay, you only have me on 200 acres, I'm made for 1,000 or whatever it's made for. And it will lower itself down from 32 output to about 15, 16 output joules, and basically like a half power. But as soon as it determines that you need more power on the line because there's a bad load, well, it automatically ratchets itself up to full power as it needs to. So that's the one thing about these. I don't know what's wrong with it. I know that the right-hand fuse holder, the cap on it won't stay in place very well, and it looks like it's been arcing or got corroded on there. So we're going to take a look at this unit. And it says 6 ground rod minimum. People are like, oh, I have 3-4 ground rod. I guess good enough. Well, it says 6 ground rod minimum for a reason. When you get to these bigger 20-plus joule models, that's where the ground system starts to really become more critical and crucial because you're paying for all this energy. If you want to save $30 or $50 on a couple more extra, a few more extra ground rods and some wire and some clamps, it's going to cost you in the long run because you're not getting all the power you paid for, plus how these things are wired up. And I'll show you here in a second. You can actually cause more harm than good when you don't have enough ground rods on the unit, just because how the Cyclops units in general, how they're built and how they're wired. And I'll explain more once I get it apart, what can cause issues for you. This is not very old of a model. We're in 2025. This is a 2022 model. So it's already in for repair. I don't know if lightning got a hold of it or if it just, or what happened. Looks pretty dang clean. Okay, so when you look at the front of the unit, the right-hand side fuse, people are like, oh, it's my fence fuse. Like, well, or the left-hand fuse, oh, it's my ground fuse. Well, the fuse on the left electrically ties into your AC side. So you see all of it over here. It's your AC surge protector board and stuff, and then you get your output fuse, the right-hand side fuse, ties into the fence, and it's there for protection for this, for the fence side, and this is your output protection board to try to help, catch things if something doesn't happen. If this fuse isn't quick enough, this will absorb some of that lightning as well. So sometimes the left-hand fuse on here for the AC side will blow prematurely or blow periodically, whatever. And the reason why is if you look at this green wire right here, underneath the circuit board is your ground terminal. This wire is tied to the ground terminal and tied to the surge protector board. And if it keeps popping the left-hand fuse and no storms rolled through on the AC side of things, no storms rolled through to pop that fuse, 9 times out of 10 or more is you don't have enough ground rods for your unit. And that goes for all the Cyclops models. If when they say 6 ground rods, that's 6 6-footers or 8-footers galvanized rods driven as deep as you can get them, 10-foot spacing between each one. String them together with some good galvanized ground rod clamps, and run that the first rod wire, run that up to the ground terminal of your fence charger. And the reason why this fuse would blow prematurely when there's no storm rolling through, but it blew the left-hand fuse, is because the ground voltage is too high. And the ground voltage can vary from 300-400 volts up to 1,000 plus. Well, anyways, that extra ground voltage, since it's on the ground terminal, it gets on this green ground wire, and that goes over to the surge protector board, and just because of how it's wired, you can actually trick the surge board and the fuse thinking there's a power surge coming in, and to pop that fuse even though there's no actual surge coming in to the AC, just because of the extra ground voltage feeds up to here, goes through this board up to the fuse. It can pop that fuse prematurely. If it does that, you need to add more rods that lower that voltage down across the ground system in general, and lessen the chance of that happening. So that's food for thought for you. So if the system calls for X amount of ground rods, don't think, oh, I got bought for 2 ground rods for 20 years. Well, these are bigger units in the way that they're designed. And this could happen to the Cyclops Brute, Cyclops Champ. It could happen to any of them on the ACs because of how they're all wired the same way up here. So do what the manufacturer says, and don't just try to save a few bucks, because now it's going to cost you whatever it's going to cost you to get something fixed. So what we're going to do first with this unit is I'm just going to plug it in. First, I want to check the fuse. This looks pretty clean. Little ear tabs on there aren't broken or bent out of the way. Fuse looks okay. But let's just check the fuse first. We can look at it, say it's good, but sometimes a little filament in there will break on the inside of this silver parts, and then of course it looks like it's fine. The only way to know for certain is to test continuity, and it's good. It beeps, so it's good. So we'll put the fuse holder back, a fuse cap thing back in there. So line up, there it goes. So now we'll plug it in. Okay, clicking, that's good. Probably need a new fuse holder put in there, because the cap that was on there, I don't know where I set it at, but it's pretty crusty. So it's probably been arcing at some point in time, or I got hit by lightning at some point in time. But let's put our fence tester across the output here. Since the fuse holder is out of the circuit right at the moment, we can't test across fence and ground, but we can at least test across the transformer right here and here. 7,000 volts. It puts out like 9 or 10, but since this is that power on demand setup, because you see these 2 little skinny wires right here, this is the power on demand wires, the feedback wires for the 2 different channels of power. Because this has a dual primary coming into, so basically it has 2 channels for the transformer on the discharge side, and it has 2 banks of capacitors. So I believe how this thing runs, it only once it determines that it doesn't need all that extra energy, it will lower itself down to a lower voltage and a lower joule output, because it doesn't need all 32 joules right now. So because the fence load that you've got hooked up to it is not enough for it to deem worthy of using all 32 joules. And that'll keep the unit from running so hot on the inside, which is a good thing. People are like, well, I paid for 32, I want 32. Well, you don't need it. You want the unit to burn up, then just leave it alone. So what we're doing now is I'm plugging these wires, and I'm going to get this small circuit board out of the way. So I'm bend it out of the way, and we're going to install a new fuse holder. I personally don't care much for the fuse holders. I don't like the push and turn type connections or cap style on there. I like the threaded ones, so I use one that's a threaded cap. So that's what we're going to put in here. I'll show you what I mean. Let me figure out. Okay, let me go grab some. I think they're over in a different area. Okay, this is the type I like to use. It's a threaded cap versus a push and turn. So I like this style better because you have to worry about the ears breaking off, arcing off. I think it's just a better fuse holder. I've installed these on lots of Cyclops units on both the AC side and the fence and ground side, and I haven't had a problem yet. And we've installed, I don't know, dozens, I guess. I mean, we've installed a bunch. The only thing you have to do extra when putting these in here is the hole inside the case is smaller. So we have to make the hole in the side of the case bigger. The way I do it, this isn't the normal one I like to use, but this is a stepper bit. And I use it kind of like a saw. I'll spin it up and I'll just use this and I'll go back and forth and kind of cut into the case. And you don't want to make it a perfect circle on the case because this has a flat edge to the threaded piece. It's kind of a D shape. It has two flat edges there. And that's for when you put it on there, so that way when it's a perfect circle, the whole thing's just going to spin on you as you tighten it up. If you try to squeeze down on here to lock the hole with a pair of pliers while you tighten up, you'll usually squeeze a little too hard and you'll crack this thing. So you want to make the hole kind of oblong teardrop shape or whatever, so that way when you turn it and tighten it down, it hits the case, and use the case to kind of help hold this thing in place. So, and you don't want to make the hole too big, so I usually will test fit it. Whoops. I'll test fit it a few times first as we're doing it, just that way I can gradually make the hole bigger as need be, and I can kind of see where I'm a little too small at, a little too, the hole needs to be widened up a little bit. Okay, just a little bit more. Might have it here. Oh, almost. This might be enough. I don't know. Oh, just a little more. I'd rather take it off in stages and be a little too. Have a little too much, too small a hole. You can always make the hole bigger, but you can't make it smaller once you go too big. There we go. Yep, and so I'll lock against the case. So that's good. So now we'll take the nut, put it on the inside. Come on. Throw away some stuff off my bench. Run out of room here. Cross-threaded the nut. Not a whole lot of room to get your freaking fingers in here. And when you cross-thread it, it didn't help anything. One other way to make it easier would take the transformer out of here. Try to move these capacitors out of the way, I guess, a little bit. That might help a little bit. Just gotta worry don't touch them. That's a little easier. It might be easier to take the transformer out of the way, but there we go. There we go. Come on. I think it's cross-threaded. I feel like it. It's twists on there pretty easily. It's almost there. sometimes, man, these fuse holders, sometimes the thing tightens up and it snugs down. Now, this one, I've had this happen to me a couple times doing this, is it like tightens so far and you're like, oh, it's almost there, and you have to snug it up. It just like untightens itself and you start all over again. But it's something to do with the threads on the little fuse holder, because I don't think it's the nut itself. It's something to do with these threads. It'll tighten up just fine like this, but put it in there, you know, it gets so far and it like respins on itself and you have to start all over again. So let's just get another fuse holder. But we got a bad one in the batch. So that one tightened up just fine. Didn't you know, come loose and start spinning back on itself again. Okay, so now what we got to do is these little tabs on the fuse holder are too small for spade connectors to stay on there. They just kind of wobble off. They don't stay snug on there. So we have to solder wires onto there. Come on. Okay, I'm tinning the wire, and I'm going to add some solder to here. Add some solder there. Oops. Okay. Whoops, I didn't leave it on long enough. Let the solder cool off and harden, and it didn't leave on there long enough. Okay, and then we gotta, basically it's gonna come up and over, so I want to cut this long enough to have a little room to play around with. I can always cut off what I don't need. So now we'll strip that back. Ow. Okay, solder that on there, let the solder cool down, harden up. So it's going to come back over here, up and over the board, so this should be plenty. Alright, so now we need to get the board, set it back down. I'll put this wire back over here so I know that this is my wire that goes on the back side of the, because this has plugs into the board up here. I want to make sure I plug it in to the right spot. Let's get the board hold on, around like that. There we go. Okay, so this wire, what's it say on the board? It says fence. I can't freaking read, it's so small. Well, it says fence, so fence wire goes there. And this wire, this is the back one on the back side of the fuse, so it goes to this tab, this other wire will go there, and the transformer, this wire goes here. But we can cut some of this wire off that we don't need. This is a little excess, so we'll cut it right here. And then getting low on spade connectors. I need to order some more. Let's see. Uh-oh. Might have to hardwire one of them and solder it on there versus plugging it in. But that's what we gotta do. That's what I gotta do until I get some more spade connectors here. Come on, get on there. Okay, there's that. Put it right there. And this wire, it goes like this. Alright, soldering iron out. Shouldn't usually have to do this, but I don't have any more female spade connectors, and I don't want to order some or drive all the way over to the hardware store to pick them up when I can just do this a lot faster. Ah, hot. Okay, we'll solder that right there. It's on there good, but I just want to make sure it's in there real good. Ow. That heat travels up that wire pretty quick. 700 and some odd degree soldering iron, it gets hot pretty dang quick. Okay. Okay, so this goes here. Now we need to replace that fuse. It says it uses on the right hand side 2 amp. Alright, 2 amp fuse on the right hand side. Let's see if I've got those 2 amp. There's that. Alright, let's plug it in, turn it on. You see a little red light down there flashing. Alright, I think we got her whooped. So not a whole lot of issues with it. Just a bad fuse holder. Just trying to blow out all them little plastic particles when I was in there drilling on stuff. I'm gonna see. I think I got some baggies here somewhere. I got these little baggies. I'm gonna send them back. Some spare fuses. Let's see, 2 amp. Put a couple spare ones in there for them. see, is it the half amp on the other side? 3/4 amp. Ooh, I don't know if I got any of those. It's an oddball size 3/4 amp fuse. Half amp. I don't have any 3/4 amp fuses, so we'll send them some 2 amp fuses. Okay, so now I'll put the screws back in. This one's done. Seal that up. Where's my fuses, or my screws at? Just make sure. Okay, just want to make sure my cord wasn't getting in the way of anything. So, well, this one's done. Okay, let's put this meter on here, and I'm going to show you something. Let's see if this... Okay. So, wow, real quick, see how... Okay. A little bit of a glare. Let's get bad glare. Okay, let's... Okay, I want to hook up my leads here on this tester. I want to show you the power on demand feature, how it shows full power at the beginning and then lowers itself to a half power, is what it does. Look at that. Terminal will come right out of there. Look at this number right there. Make sure you can see it. Okay, you can see it just fine. Okay, so we're going to plug it in and we're going to get peak voltage out of it, no load, and watch the voltage. It starts off high and then it will drop down to a lower level, I believe is what it should do since it's been off for a little bit. Say 9.5. 7.7, 7. So, see how it dropped down to a lower level? Took about 5 or 6 pulses. As this power on demand, it realizes, okay, I don't have hardly any load hooked up to me. So I'm gonna lower myself down to a lower level of energy because I don't need to use all 32 joules. So now we'll put to a 500 ohm load and we'll see what the joules and the voltage does. 500 ohms shouldn't really make a difference to this thing. It's going to basically laugh at it. So at 21 joules right now. We're down to 13, 4.5. It's gradually ramping itself back up. right, turn this off for a second. Let's go to a 200 ohm load. This is even heavier. So you're at 13 joule output. Go to 100 ohm load. See, at 8,000 volts at 33 joule output with a 100 ohm load. See how it ramped itself up? That's at 100 ohm load. That thing's working pretty dang hard and heavy, and still sitting at about 8,000 volts. These things are no joke. These are a very, very, very powerful unit when they need to be. See, we're at 13 joule output at 6,000 volts at 200 ohm load. See, it's adjusting itself on the fly as it needs to. Boom. Full power at 100 ohm load. These things are no punk. These things are a potent unit. So, but that's how you can see, you know, these things don't run at full 32 joule all the time. All right, well, thanks for checking us out. This unit's done. We'll call the customer up and give them the quote. I'm sure they'll fix it. But anyways, thanks for checking us out. Until next time, see you later on.